Hey there! You know that feeling when you're looking at your own code and it's just this mess of if statements nested inside other if statements? Yeah, we've all been there. Well, today we're going to fix that. We're going to learn a few simple but super powerful tools to untangle that code and make it elegant. Let's dive in. Just take a look at the difference here. On the left, that's the kind of code we're talking about. Sure, it works, but good luck trying to figure out what it's doing a month from now. And on the right, that's where we're headed. It's the exact same logic, but it's clean, it's simple, and it's all in one line. The magic behind this is something called logical operators, and that's what we're here to master.
So here's our game plan. We'll start by quickly touching on why this all matters. Then we'll get to know our three best friends for writing clean, conditional logic: the flexible or, the strict and the opposite not. And finally, we'll see how to combine them all to handle some really complex decisions with total ease.
All right, so first things first, why should we even care about this? I mean, if the code works, it works, right? Well, not exactly. That messy, nested code is like a trap you're setting for your future self. It often leads to repeating yourself, and if you need to make a change, you might have to hunt it down in 3 different places. You miss one, and boom, you've got a bug. Simpler code isn't about being fancy, it's about being readable, easier to fix, and saving you a massive headache down the road.
Okay, let's jump into our first tool. This one is probably the most flexible of the bunch, the OR operator. This is your go-to when you've got a few different conditions, but you only need one of them to be true to move forward.
Here's the key thing to remember about OR. It creates a single question out of many, and that question is true if at least one of the parts is true. It's basically looking for just one yes to give a final yes. The only possible way for an OR expression to be false is if every single one of its conditions is false.
Let's make this a bit more real. Imagine you're planning your weekend. You decide, okay, I'll go to the park if my friend is free or if the weather is sunny. Notice you don't need both of those things to happen. If your friend is busy but it's a beautiful day, you're going to the park. If it's cloudy but your friend is free, you're still going. Just one is enough.
Now, in JavaScript and a lot of other programming languages, the symbol for OR is just 2 vertical lines, or pipes. When you see this symbol, your brain should just translate it to OR.
And here is our weekend plan written out in code. It's as simple as if friend is free or is sunny. If either one of those variables is true, the code inside the brackets runs and we go to the park. See how clean that is? It perfectly captures our intention in one simple line.
All right, time for a quick check. This code here will tell you to wear a jacket. So, when does that message pop up? Well, remember, it's an OR. It'll trigger if it's a chilly but sunny 35-degree day, because 35 is less than 40. It will also trigger on a warm but rainy 60-degree day, because the weather is rain. As long as one of those conditions is met, you're getting that advice.
Okay, on to our next tool. Sometimes being flexible isn't what you need. Sometimes you have requirements, and multiple things must be true. For these non-negotiable situations, we bring in the strict AND operator.
Unlike our easygoing OR operator, the AND operator is an all-or-nothing deal. The entire expression is only true if every single one of its parts is true. If even one little piece is false, the whole thing is false.
Back to our weekend. Let's say you want to go hiking. For this to happen, 2 things are absolutely required. 1, you have to have your boots. 2, the trail has to be open. If the trail is open but you forgot your boots, nope, no hiking. If you have your boots but the trail is closed for maintenance, still no hiking. Both conditions have to be met.
The symbol for the AND operator is 2 ampersands. When you see this, you can think of it as meaning and also.
And here's how that looks in code. If have boots and trail is open. The program first checks is have boots true. If it is, then it checks is trail is open true. Only if the answer is yes to both does it run the go hiking code. It's a strict check, perfect for when you have multiple requirements. Okay, let's test our understanding of AND. This code tells you to take an umbrella. But when? It's only going to happen under one very specific scenario. You are walking and it is raining. If you're walking but it's sunny, no umbrella needed. If it's raining but you're in a car, you're fine. Only that exact combination of both things being true will trigger the alert.
So our last operator is a little different from the other 2. It doesn't combine conditions. Instead, it reverses them. This is the NOT operator, and it's super handy for checking when something isn't the case.
You can think of the NOT operator like a logical light switch. It takes something that's true and flips it to false, and it takes something that's false and flips it to true. It just inverts whatever value it's given.
Let's finish up our weekend planning. You decide that if it is not sunny outside, you'll just stay home and read a book. Notice, you're not specifically checking if it's rainy or cloudy or hailing. You're just checking for the absence of sun. If is sunny is false, you're staying home.
The symbol for not is just a single exclamation point. You put it right in front of the value or variable you want to flip.
And here it is in action. That exclamation point right before is sunny reads as if not is sunny. So if the is sunny variable is false, the not flips that false to a true, the if condition passes, and the code inside runs. It's a really clean and concise way to check for the opposite of a condition.
So now that we've met our three operators, or, and not, we can start to combine them. And this is where things get really powerful. You can start to build some truly sophisticated and detailed logic into your programs, all with very clean code.
Now, just like in math class, there's an order of operations. The computer will always evaluate any nots first, then the ands, and finally the ors. But honestly, here's a pro tip. Don't try to memorize that. Just use parentheses to group your conditions together. It makes your code so much easier to read and removes any doubt about what you want to happen first.
Let's look at a final plan that combines these. We'll go out if our friend is free or it's sunny, and it is not raining. See how the code handles this? The computer first looks inside the parentheses, is friend is free or is sunny true? It gets a single yes or no from that. Then it checks the second part, is it not raining? Finally, it checks if the result of the first part and the result of the second part are both true. It's a complex rule, captured perfectly in one line.
And this really gets to the heart of it all. These operators, and, or, and not, they aren't just little tricks to make your code shorter. As the slide says, this logic is fundamental. These are the building blocks. They're the software version of the physical logic gates inside a computer chip. By mastering them, you're not just writing cleaner code, you're starting to think in the core language of computing. So the next time you see a tangled mess of if statements, you'll know exactly what to do.